Hi, everyone. Welcome to our VictoriaMetrics Tech Talks. This is episode 7, where we're going to be continuing our looking into AI and ML in observability. In our last session, we talked about MCP server and interacting with it. And today, we've got a special guest. Fred is with us, and Fred leads the team for vmanomaly. So we're going to really look into machine learning and how anomaly detection functions alongside AI and ML, and where we go. Matthias and Fred, you want a quick intro to yourselves?
Sure, I'll go first. I'm Matthias Palmersheim. I'm a solutions engineer at VictoriaMetrics and happy VictoriaMetrics and Victoria Logs user.
Hi guys, thanks for having me here. My name is Fred Navruzov. I'm representing VictoriaMetrics anomaly detection team, and today we'll touch some of the internals of vmanomaly and how it interacts with VictoriaMetrics, how it follows the direction of VictoriaMetrics, what it does, what it's best used for, and how it works, as well as some practical tips of how to use it properly.
Yeah, and we are attempting the demo gods again this time with, I believe, 2 different demos of this. So we'll see how that turns out. Go ahead, Matt.
I will not be editing my config files on stream this time. I learned my lesson from last month.
Well, anybody on Polymarket, if you want to bet on what's going to go wrong in this tech talk, the markets are open. All right.
Do you have an affiliate link for that one, Mark, or no?
Not yet. That's the gambling wall behind me. Yeah. Cool. So yeah, and you know, we've since our last talking again, we do it the last Thursday of each month. Just wondering if Matthias, if you ran anything with anomaly detection or interesting around AI ML, working with users or just on projects yourself over the last month.
I have been playing more with LLMs to do stuff. So I had a nasty accident with my router where it just decided to give up in random 5-minute intervals. And so I've always wanted to just figure out if I just used a Linux box for it, if it would work. And I started coding in Go. And for some reason, I don't know if I'm just a bad AI supervisor, but I actually had a better time learning Go than I did having a LLM to do it. But I think it was probably due to using Qwen instead of shelling out for Claude or a hosted version of Qwen, because my graphics card can only do a 30 billion parameter model instead of Qwen 3's 230 billion parameters and 32 billion active.
It's hard to keep on top of all the stats of them now where they're competing. So yeah, and I messed around a little bit. I started using unfortunately a proprietary AI IDE, and I know I got to change it, but I managed a couple of applications that I've been trying to write for years that I get stuck in complexity. It helped me through, and it was also the interesting part for me was learning Firebase and Go as I went through it. So that was pretty neat. And Fred, I guess you've been stuck in the ML world full time, right? With
right, anomaly? Right. And from your side, it looks like, and it sounds like you're already both in 2026, yeah. And I'm still in 2025. But however, I had also kind of good updates from vmanomaly side, so we made it more scalable. We introduced only awaited features like config control loads and stateful mode, and we also added a couple of tweaks for some of the modes like auto-tune that we have. And then we also worked around some of the visuals and internals. So it was a busy half a year and busy months, but in general, it all went well. Hopefully it went well also in this tech talk as well.
And
so we'll follow.
And the big win for having stateful vmanomaly means you don't have to retrain models every reboot, right?
Yes,
because what would happen before is that the model would have to retrain every time it restarted because vmanomaly didn't have a place to store all the pre-trained models and everything, right?
Yeah, similar to other components, it was almost stateless. So that's why when you need to adjust some of the configuration, or if you want to add or remove some of the internals, for example, you'd like to put in some new model, or you want to blacklist some of the existing queries, you should manually restart it. And after all these tweaks, now you have both stateful vmanomaly and you have hot reload. So once you have some adjustments to your config, it will be propagated and properly handled by vmanomaly itself. So as long as you have some of these in your config that can be reused, it will be reused without explicit retraining, without additional load being put on VictoriaMetrics time series DB to get this data. So everything went better.
Yeah. And that's really nice too, because before, if you wanted to like backtest, that would mean you'd have to retrain the models, right? So if you just added a backtesting scheduler to test to see if something was anomalous that happened in the past, you would have to reload and retrain all of those models. But now you just edit a YAML file and it just works.
Yes, it adds one-time job, and it just does the job, and then it finished. And your production scheduler continues working as expected.
I guess that could be a huge time saver. I wonder if somebody's built and trained a model and then they have to restart it, and it's not just the training time, but it's the lock of visibility into that output through retraining. So one question I have, and it might be too elementary, and let me know, guys, if this is a silly one or not, but I'm the AI and ML, right? We've got machine learning and anomaly detection and AI. In my mind, in a Venn diagram, they're very crossed over. But is there anything that you guys can share that's just a clear distinction between what falls in a pure ML and anomaly detection versus an AI?
Fred, can I give the silly answer before you give the technically correct answer? The silly answer I've heard, and I forget who said it, but basically as soon as a feature is stable and it works, it stops being AI. So there's been like a whole bunch of stuff that we already have, like sentiment analysis and like page ranking and stuff like that, that used to be considered AI, but now that it's ubiquitous and it works reliably, we don't call it AI anymore.
Okay.
Yeah.
So that's the silly answer.
Nevertheless, it's almost technically correct, because if we take a look at historical perspective, everything is called AI. It's the biggest bubble in Venn diagram. So everything that a computer can do without being explicitly asked to, or without being explicitly algorithmically computed, then can be considered an AI. So even simplest algorithms can fall in this area. I mean, the simplest ML algorithms, for example, or some statistical models. Then goes ML. This is mostly about the models that improves the performance as long as they see more data, or as long as they adjust to more data. But they have also some of their theoretical limitations in what abstract work or they can do. And then we have deep learning, which is the fancy stuff to generate stuff, to analyze things, to do translation, or to do some sequence-to-sequence job. And then inside, hopefully in 1 year, we'll have artificial generalized intelligence, which is considered true AI. So I also don't like to mess up with AI term being put everywhere, but technically it's still correct. Yeah. So if you are using AI, you can still use term AI.
Yeah, and I always look at AI. Any computer is using machines and they're learning, right? So I kind of flip it around. I'm like, well, everything is machine learning, and AI can be anything. It's a mess. So, yeah.
And all of us are biological AIs, biological machines as well.
Because object detection used to be like the hot thing for AI before LLMs, right? Everybody was trying to figure out object detection, but now that that's somewhat reliable and ubiquitous, like without having specialized hardware, my image server can recognize faces pretty well. And we don't call that AI anymore. We call it image detection.
Well, when you said that we're biological AI, I totally agree with that, and it explains why sometimes I just hallucinate. So
that explains much of the things. About how we operate.
My training data is being limited, so you get what you get. Awesome, guys. Well, that's great, and this is, I think, a perfect segue into going into. So machine learning is, that's what anomaly detection leverages. Let's just sort of set the stage on anomaly detection in our world. What do we define it as, and then we can hop into how we use it, how we built it, where it came from in our mindset, and then talk about the sort of good use cases where it's good and things that we know where it's anomaly detection is not a right fit, and really get into that and cover some best practices. And of course, anyone who might have any questions while watching this, please feel free to enter the questions. We'll try to address them right away. And if not, we will we'll answer them at the end. So at this point, I'd like to,
sounds great. Can you please have, here it is. I prepared a couple of visual slides to just follow up what will I say about anomaly detection in general, and anomaly detection for time series, and anomaly detection as unsupervised technique that is used for time series data or for metrics data in particular. So first of all, I'd like to share a couple of things about what is anomaly detection, so we are all aligned on terms. Of course, there can be different terms, and throughout ML world, everything uses slightly different terms, but they all intersect in general. So even before we touch anomaly detection for time series, and time series, it's some process measured over time where you have temporal axis, when you have some measurements, usually over some moments in time. So you have another axis of complexity, which is time. But even for anomalies that do not have this time axis, anomaly is usually about some entity, maybe single data point, maybe some object, maybe pattern that deviates significantly either from the rest of the objects or either from expected behavior, whatever you put in this expected behavior term. So it's defined by business logic, by context, and by the guy who defines the both, actually. And going to time series, which is specific subset of anomaly detection, and time series is a specific subset of data because it has time axis and it has sorting order. So you can't really see the future, and from future you can predict the past because it's meaningless. But in different tasks, you can mix your objects, you can put it in the buckets, and it still be okay because you do not share or do not expose forbidden information that can affect your prediction quality or your anomaly detection quality. So it's not anymore for time series, and here you should be cautious. And for time series, I would say that anomaly can be a single data point, which you measure over time, or maybe a pattern of data points that deviates significantly from expected behavior. So we try to keep the term simple. Also, it can reside in some spikes, maybe dips or drops, maybe some unusual mid-seasonal patterns, and we'll address what is the seasonality later on. And all of this cannot be really explained by some regular fluctuation or trends in the data. Maybe the reason is something else. And the reason can be many, like the errors in data collection. Maybe a sensor that sends data is malfunctioning. Maybe you have sudden changes in behavior. That's real classical anomalies that we all want to detect. Maybe it's data drift or some rare, hardly foreseeable events like epidemic or something like that. So almost everything can affect the state where you can see this unexpected behavior. But for time series, there can be kind of specific types of anomalies that are not seen or is rarely seen with different contexts or with different data types. One of these is so-called contextual anomaly, where we have data points of similar magnitude over time, but being seen or being observed in one context, they can be completely normal, but being put in different contexts, they can be seen as outliers. But if you put a single line, you either isolate all of this, so you mix false positives and true positives, or you either capture none of this if you set it too high. And that's one of the cases where just simple alerting rules or expressions that operate on raw metric values, it can't really work, or it works with some considerations, with some limitations. Another option is about so-called collective anomalies, where we have a lot of data points or a set of data points that all reside within expected data population or data distribution. So if you put some of the lines, they will be still within the boundaries, but instead they collectively form some strange pattern, like a lot of small transactions, a lot of small requests, a lot of throttling, maybe something else. So if considered one data point at a time, they can be seen as normal, but if they form some continuous behavior, it can be considered as collective. Sometimes collective.
Sorry, you mentioned just a minute ago, sorry, I thought there was a pause. I didn't mean to cut in on you. You mentioned earlier that like an alerting rule wouldn't work in that way. Is that because you couldn't define all of the permutations of what is, quote, anomalous, right? Like you'd have to have the most predictive query or rule set ever, right? So this is...
it's hard to address just because one of the queries that you define may return different time series. They can have different patterns. They can have different magnitude. Like one of these can be orders of millions. One of these for smaller entities can be orders of tens or thousands. And you can't really craft one single alerting rule that rules them all, or one single expression on raw metric values.
And a lot of the way Prometheus and VictoriaMetrics are built, and most time series databases, they're designed to reflect the current state of things. And so there's a lot of like seasonality and stuff is really hard to detect using PromQL or MetricsQL, because those languages are designed for like how to interrogate the current state or historical state of a system, not human seasonality. So the more succinct way I put it is Prometheus thinks in time relative to now, or VictoriaMetrics thinks in time relative to now. But the way we think about time is calendar time. So if you have weekly or monthly seasonality, articulating that inside of MetricsQL or PromQL is extremely tricky. Whereas if we just take those query results and put it into Python, which is what vmanomaly is written in, you get to take advantage of all the ML goodness that exists inside of Python.
Yeah, exactly. Because of the internal designs for most of the observability stack, it is somewhat limited. It's not fully limited, but it puts some limits and some considerations into how we can utilize the data, how we can query this data, and how efficient it is, and what we'd like to get based on top of the results, actually. Because
even something as simple as like querying the current month gets really tricky inside of MetricsQL and PromQL because of, again, it measures time relative to now. So you basically having to do like an if-else statement that covers like February has 28 days of the year and July has 31 days.
It also doesn't account. It also doesn't account for DST changes or any other tricky things that can happen.
So just a lot more places to have things.
TLDR, it's complicated. It's complicated.
Yep. This is the easier button.
And the third type of specific anomaly for time series is when you observe not only one time series but several at a time. For example, consider some of the metrics like CPU utilizations per instance or per some application, maybe RAM utilization, maybe disk I/O. And when you observe all of this time series all at once, you can see some strange patterns. But if you observe it one by one, they look normal. Like they have expected data range, they either low or high. But if you combine them together and you either expect your CPU and RAM being high on peak hours or low when it's doing nothing, for some reason you see low-high or high-low, and that's not expected, and maybe that's requiring some further investigation. So this is how vmanomaly world, which operates in time series and anomaly detection in time series, differs from regular data, and it has some complications added to time series or to metrics, which is more common term for our viewers or listeners, I believe, because in technical term, metrics is time series plus some labels, so it's still something measured over time. So in general, what is exactly anomaly detection in our use case is just identification of such unusual data points or patterns or behaviors within some given time frame, because we have time. Later on, I'd like to spend a couple of minutes to express how vmanomaly was built and how it followed the build process of VictoriaMetrics as a company and as a set of observability components and instruments. So here you see that VictoriaMetrics is quite, I would say old, but it's quite stable and it's quite established. So as long as VictoriaMetrics team have built an infrastructure and database and ecosystem for metrics data, Then it switched to different pillar of observability, which is logs data. So we introduced Victoria Logs, like a database and ecosystem for logs. Then we start doing POCs, and quite successful POCs, I believe, on Victoria Traces, which will shortly follow. So it will be a third pillar of traces support, and then, or in between, actually, it's all happening in between. So it won't happen just in 2026. It's already happening for all the pillars, but by the end of the day, we'd like to have a synergy. So we would like to have united ecosystem for observability, like a Go tool to unite every aspect of your data about observability and have some meaningful insights on top of it.
Yeah, I think
so when it comes.
Oh, good. I was just going to say it's advantageous, I really think, to have vmanomaly be able to look across all new pillars of observability that VictoriaMetrics or anyone's putting these solutions out for, is being able to then connect that all, because there's so much relation between your metrics, your logs, and your traces to identify what root cause is or prevent things. So that's
exactly
a lot of work
exactly.
To stay into that.
And there's already some real world use cases where it'd be nice to be able to query a log source instead of a metric source, because they have like the IP address as a part of the fields inside of the logs, and storing that as a metric in VictoriaMetrics isn't sustainable because that IP address changes so much. They would hit all the like self protection for, hey, maybe you shouldn't query 10 million time series at once. Whereas if it was a field in a log, we would be able to query it and aggregate it away. So vmanomaly would only see the one time series that it would care about.
Yeah, so it's a kind of natural evolvement over time when it comes to VictoriaMetrics progress, and the same goes for vmanomaly. So personally, I joined the vmanomaly team. Well, I'm quite old here. I believe it was the mid of 2023 or something. So by the time we have vmanomaly available, it was first public releases, but awareness was low. It was no public ways of distribution, no public talks, so it was kind of hard to find and to use it. So one of my first goals was to make it shine, or to make it available, and make our guys fully aware of what it is, what it can be used for, what it does. And so we made it public. We started with anomaly detection for metrics, obviously, because by the time we had metrics database and metrics ecosystem. So right now, vmanomaly is fully exposed to the audience. Like you have docs, you have distribution mechanism, you have image registries, you have deployment options like vm operator, Docker images, Helm charts. You have product page if you need more business audience being involved. Natural expansion would be to contribute into ease of use, so it's not only for engineers, but it can be for everyone, as well as to add additional pillars inside vmanomaly, because vmanomaly is considered as a layer on top of VictoriaMetrics pillars, a kind of explainability and observability pillar, or layer, better to say. So expansion would be made on logs. We also introduce vmanomaly graphical user interface, and as was mentioned previously in previous talks, we'll have similar options for developing MCP server for vmanomaly. So its endpoint can be also querying as tools, resources within broader context, so they all can be united. And as for any other components and ecosystem in general in VictoriaMetrics, we will have plans to make a unification. So we'll have united ecosystem for observability. We'll have MCP servers. We'll have not only assistant modes, but agentic modes on top of it, because we believe that this is the future of how observability should be taken or should be done. So here, vmanomaly is falling maybe half a step behind the development of VictoriaMetrics, because it relies on VictoriaMetrics and the ecosystem which is built. That's I wanted to tell about how vmanomaly was built, and how it's maturing, and how it will be made in the future. Yeah. Like what steps should it take?
I think as adoption is going up in this, like vmanomaly, we've seen a more uptake in it. Just wondering about people that have feature requests or or feedback or anything. It's just at a high level, what's the best way for anybody who wants to get rolling with it to provide feedback or get hands-on?
Yeah, let me first make a step back, and for the guys for the audience who may not know that vmanomaly is a part of our enterprise offering. So it's not a part of an open source repository, so you cannot really go and add some bug or feature request. So in general, it can be made via our private Slack or via public channels in our public Slack. It can be also done via forms in our site. It can be also done through VictoriaMetrics mono repository, because you can also have vmanomaly labeled there, I believe. And we got a couple of requests. But majority of requests, of course, are coming from specific customers or POCs. Like, it was very nice to have this small feature. Can you add it? And we are quite open on that end. And once we see that it works and it is alive, we can definitely add it in very small time window.
Because especially a lot of the daylight savings and other time-based features were all customer requests, right?
Correct. Like, it's not a common use case, but twice per year it's a common use case. And once you have a customer that already had this issue, it's better not to have this issue anymore.
Yeah, well, it's an issue twice a year in many different places too. In some places, it's not an issue, which is an issue. So
yeah. Especially for the customers who operate in different time zones, and they have a lot of different seasonal-based time series.
Yeah, time zones are my kryptonite.
They're everyone's kryptonite. There's a really good Tom Scott video that goes through like, hey, I want to make a time zone library. And then it's just like, oh, this is easy. And then DST happens. And then DST in Europe happens different than America. And it gets all the way into the, like, it ends up turning into political conflicts because there are different different places that are on the same place on the earth that have different time zones.
Yeah. Hey, on this, a question just came in, guys, from Sandeep. Is VM capable of using virtual GPUs for better and faster performance? So is there any GPU-based acceleration on this, or is it CPU memory?
For now, CPU memory is enough, because most of our built-in models, they just reside and rely on CPU. They are kind of simple, so we are not operating on some foundational models that require a lot of GPU resources, maybe even TPU, just to predict one data point at a time. So we, one teaser in advance, we also support custom models. And for custom models, if for some reason our customers would like to plug in some really heavy models that rely on GPU utilization, we can support that as well. But it's not needed to run vmanomaly in its default mode.
Because
fits and infers are fractions of seconds or maybe milliseconds already. So it isn't that much that should require GPU acceleration.
Yeah, I was going to say in my lab, it's hardly noticeable. We can dig into the metrics when we're in the demo section, but it's, I think, using less than 1 CPU and 1 gig of RAM in my home lab of like 20 servers. And that's detecting anomalies for like host metrics and every endpoint in my home lab.
And I guess that's the benefit of having a focused solution on this, right? Is where an agentic AI system has to be prepared for anything. This is being tuned for these specific use cases. So the performance is there, maybe not all the flexibility of that. So
yeah, we also have to abide overall direction of VictoriaMetrics. So as long as VictoriaMetrics can be run on small devices, or it can be run on-prem or in cloud, it can support different options. So we need to support at least decent and small models that can operate on specific time series, instead of just putting some big foundational model and say that it works for everyone. So it's really tempting, especially from a data scientist perspective, just to throw in some foundational model for forecasting or maybe for anomaly detection and hope it works for every use case. But as practice showed, it's not always the case.
And we do have ways of scaling VM anomaly beyond like what a single container or a single box. That's something else that's happened in the past year is you can run vmanomaly
Correct.
as a sharded config. So there's no complicated elections or leader election or anything like that. vmanomaly can just know which number it is in the group, and then it will split out the config based on what number of the group it is and what partition or partitions it has. And that's also how redundancy is handled. So say you have a group of 3 vmanomaly instances, and you want to run each thing twice, it'll break up to know that node 1 will get the first 2 chunks of it, the second one will get chunks 2 and 3, and the third instance will get chunks 3 and 1. And it's tunable how you can partition the config too, right?
Yes, you can split it by different sub-entities, and for that we have clear documentation, but Mathis, you worked better than our documentation, I believe. So this was one of the achievements that we made in the early 2025. So we added sharded mode and high available mode for vmanomaly. So as long as vertical scalability is not more enough, then you can shard your global configuration into several sub-configuration, but you still have a single entry point. And I believe we are touching some of the things that should be addressed on later slides or throughout later presentation, because it might be unclear at this point in time what we are talking about actually.
Yeah, we're getting deep into the inside the sausage factory. So
it's always
sorry about the spoilers.
Yeah, so don't worry. This presentation or this tech talk won't be not about the talks and not about the showing some presentation. It also have some live data, so don't worry. These slides are just for onboarding into what we're doing here and what vmanomaly is used for and what it is exactly. So for the audience, I believe the safest way to perceive vmanomaly is to think of it as a ML-powered alerting rule. So if you have VictoriaMetrics ecosystem, or if you have similar prompt-kill compatible ecosystem with tools like vmalert to produce alerts, then what you do with the help of vmanomaly, you substitute your expressions in your alerting rules. So you don't need to continuously maintain them or change the thresholds, change the expressions, change something else once you have new data or new logic. Instead of this, you rely on a so-called anomaly score metric, which is produced by any model of vmanomaly, which has constant interpretable threshold. And as long as the models are retrained over time, this threshold remains interpretable and the same over time, and it remains actual over time. So you can have your alerting rule expression as simple as anomaly score, maybe with some filters, greater than 1. That's what you throw in instead of your previous one, like some metric name multiplied by something greater than something for some time, and then it should be reevaluated because your magnitude has changed.
And a small correction, vmanomaly is ML power recording rules, not alerting rules, correct?
Correct. It's a typo on the slide. Yeah, so basically, and that's what on the next slides, vmanomaly itself produces a metric called anomaly score, as well as some other metrics, but anomaly score is in its core. So anomaly score is a metric which has float values from 0 to plus infinity. Here you can see it on the bottom graph, and you'll see it a lot on Grafana dashboard, which we'll present today. So in general, on the uppermost graph, you'll see your original metric, which has some multiple seasonalities, maybe intraday, maybe weekdays versus weekends. And it's harder to set up some alerting rule with decent threshold on raw metric values. But instead, if you set it up on anomaly score metric, which is below, then it's detrended, it's deseasonalized, it has it also descaled. So this 1.0 threshold remains actual, and this dashed line is the default, reasonable default alerting rule that we suggest, like anomaly score greater than 1. And simply speaking, each time that you have some unexpected behavior which is not covered within prediction interval, that's been said, you'll have your anomaly score spiking above 1. And once you approach this boundary, you'll have anomaly score approaching 1 from below. And the more you have these anomalies, the more you have anomaly score. Like anomaly score of 2.0 is bigger anomaly if considered or if compared with anomaly score of 1.5. So it has monotonic behavior. It has an interpretable cutoff point, which separate non-anomalous from anomalous point. And it really simplifies your alerting rules. And in general, that's almost the first questions that we got asked about vmanomaly from the leads or from the POCs. So what's vmanomaly used for? So in general, it's to reduce mean time to react for observability use cases and currently for metric data. A side effect of this is to simplify maintenance and support of alerting rules and thresholds. And as a different side effect, you spare some of the precious time of your engineers or your SREs so they can spend it on something else which is more important than just gradually redesign alerting rules from time to time. The third one is to handle complex metrics, and I will shortly change into my Grafana dashboard to make an example of what is complex metrics and what isn't, where the constant threshold just doesn't work. For example, like this. So here you have some seasonalities. Also, you can have some trends where your data is gradually increasing or decreasing over time, and something other weird behavior as well.
Yeah. Fred, on point number 2 that you have on there to simplify the maintenance of alerting rules and thresholds, I think that's probably a very underlooked one. Like I know I've not as a seasoned administrator at all, but I've had to go in and work on other people's rule sets, and they're all interconnected, and it's like it's pure spaghetti code and spaghetti alerting where it's really difficult. So a lot of people then just create a new set of rules. So you've got multiple rule sets chasing things. So it would be correct in assuming that by adjusting with anomaly detection, I don't have to worry about all of the ingredients. I'm more worried about the output, right? Is that
correct? But that's a funny thing because from a majority of the feature requests and lead requests, they are not asking at first, as a first case, about anomaly detection. They are asking of how we can simplify maintenance with our alerting rules, because we have a lot of false positives, we have a lot of time spent on maintenance, we have a lot of other connected problems. Can you help us? And when we dive deeper, we understand why they have this. Like they have some interconnected metrics, they have some complex metrics profiles. For that, they would like to gradually change thresholds over time, and that consumes precious time. So this is the cause, but the reason is the maintenance.
Yeah, I'd be curious to see if there's any statistics out there about how much of alert fatigue is actually driven by bad alerts or old alerts, right? Like
I wonder if we could just like have a survey. Do you shudder at the sound of this notification sound at a tech conference or something like that?
Yeah, it's a kind of quantitative or qualitative feedback that we can receive. It's almost the same as for the data. Like you collect some of the data or waste amounts of data, but 90% of this isn't even queried at all. You just collect and collect and go. The same for alerts.
One question that we get a lot is, can I just turn on anomaly detection for everything? And the short answer to that is you probably don't want to. So the reason being is that for every metric or every time series you perform anomaly detection on, you generate at least one more time series to track the anomaly score. And you could also, we'll show this in the demo, but you'll get like min expected and max expected values. And so there's like a right amplification problem. So if you had all of your metrics that had anomalies detected on them, you would have to store at least twice as much data. More likely it would be 3 or 4 times as much data. And as Fred pointed out earlier, and as the unused or as the metric usage API feature would indicate, there's a lot of metrics that aren't even being used by a lot of people.
Yeah, and by the way, there is another reason for that. Just because for the products like vmanomaly, regardless of the name of the product, what the people want to do with the help of such products, they want to replicate their root incident drill down, they have as a procedure. And for procedures, they usually operate on several alerts, maybe tens of metrics, and that's it. So it's not a good practice to cover everything of your data, of your metrics data with alerts, especially with different alerts. So you get overwhelmed with false positives, or you configure it in that way that it won't be ever hit. For example, CPU utilization at 99%, and all of your utilization is below 18, but for some time you have 40, and then it spiked twice to 80, but you still don't know about it.
Yeah, and I think we'll dive deeper into this when we start to show what are some of the best practices in the demos, because there's certainly, you have to understand your business logic and the technology stack you're using in order to figure out what to be watching. So there's sort of some good starter points that we'll go through, and sort of what a user journey is like. So, cool.
Yeah, so whom is best to start, from your use case, Mathis, and from mine?
Yeah, so I have one use case that started to come up at my previous job, but then ended up spilling over into my home life. So at my previous job, we were trying to get service owners to give us service level indicators, or SLIs, so measuring the success of the application that they were responsible for. And the struggle with that was they didn't know like how to measure if their application was responding fast enough or responding correctly. And my kids were also complaining at home on our home network that, hey, the internet's being slow. And so to kind of figure out what slow means, because my kids can't measure latency in milliseconds, I'm a failure as a stepdad for not teaching them that, apparently. But I was able to measure application latency using Telegraph to just periodically go to a website. And then Fred was able to help me generate a configuration for anomaly.
So,
or for anomaly
before
detection.
Before you get into that, Matthias, what do you use for your internal trouble ticketing system for your kids to report these problems to you?
We actually do pay for Asana for our home to track chores.
I love it. I love it.
I've heard somebody else was using Jira for it and said the boundary for when it's acceptable is OKRs. If you're setting OKRs for your kids, that's too far.
Yeah, I've heard similar stories about submitting tickets in Jira for cooking or for something else if you need it.
We actually do that for our shopping list.
Oh boy.
You went too technical.
It's actually super useful though, because like right now, if my kid needed something, they would be able to just like submit a ticket in Asana and I wouldn't have to interrupt this time. Even like just talking about your feelings, submitting a ticket is actually super helpful, if not too nerdy.
And for method stuff, do you have retro sessions?
No, we don't. I think that falls in the bucket of OKRs.
Good to know.
So yeah, this is the HTTP and DNS anomalies in my network. And what you're seeing here is seeing the response time of my Jellyfin server. And here you can see that there was an anomaly. Let me turn off the annotations. So the nice thing about this dashboard is that you can see what vmanomaly expected the value to be, what the actual value is, and then the expected range. And you can see that once the value significantly deviated outside the range, it had an anomaly score of 1, but the rest of the time it was all zeros. And the reason why it was all zeros is that we have the min deviation from expected, so that way we don't get false positives. So if it's just above the threshold, like it is at this point, where the upper expected was 183 milliseconds, but it was 201, it didn't spike. I believe I have the minimum deviation has to be 100 milliseconds. So here, when it actually did spike significantly and we were far outside of the range, we did see an anomaly score of greater than 1.
Yeah, and by the way, there's a different story behind such parameters, because we spent a lot of time internally tweaking some of the models to get good results, for example, for the presets that we made, but we fell cheap because, and we fell short, because it's hard to address it just by purely doing some hyperparameter tuning of the model, because you can't foresee everything from business perspective. But instead, if you put different components, which may sound quite simple, but they drastically reduce a lot of false positives, amount of false positives that you may have. For example, one of these, as Matthias said, is minimal deviations that you want to address. Maybe it's deviational from time series perspective, but from business, it's worth nothing. So you won't be able to get this notification because you are not interested in this. So it can be configured on the model side. The same can be done for utilizing different business argument, which is called detection direction. For example, you have things like error rates or maybe response times where the drop is actually good, and for some reason nobody complains when it's dropped. But instead you'd like to be interested in spikes. Then you define your detection direction for specific model set to above expected, and only spikes are being captured and drops are ignored. Vice versa for some SLAs or maybe customer satisfaction rates, where you are not really interested when it goes up, you silently praise it yourself, but when it goes down, you want to be notified. So that's a case of how a couple of tweaks can reduce the amount of your false positives, like in 10 times more than just tweaking the model.
And we actually have an example of that on the same time series for HTTP latency. We have dips that would fall below, but because we only care about the application becoming slow, we just have detection direction set to positive. And you could also like clamp the expected values too, right? Because there are some things like host metrics where we don't necessarily care if the CPU usage will always be between 0 and 100%, or 0 and 1 if you're using node exporter, right? So we could tell the anomaly detection model that, hey, this will never go outside of these bounds. So even though anomaly detection and machine learning is extremely powerful, having those those business logic parameters inside is super helpful.
Yeah, so it's more about having some end-to-end systems instead of just relying on some model type or some new article being published, like this model will solve everything that you have. It's better to have different stages combined together so they work end to end, and vmanomaly takes its place as a part of a bigger observability picture. So it produces anomaly scores. These anomaly scores are metrics. They can be sent back to VictoriaMetrics, and based on this, you can build your own Grafana dashboards. You can utilize our own Grafana dashboards. You can use it in alerting rules. So it's still modular architecture, and as long as you have this anomaly scores, you can simplify alerting rules and maintenance. You can observe what's being produced, and you can combine it with different tasks like visualization or alerting or notification.
Because so both of these
should be doing its own job and doing it good.
Because both of these dashboards I made myself without having to even talk to you or talk to somebody that knows about machine learning. And the configuration for the host metrics dashboard, I was just able to take the node exporter preset that we have and tweak it so it fits Telegraph, and sometimes it works. We actually have an example. I switched to the host metrics dashboard I have. And again, that has a good example of detection direction and clamping. So we could see that the anomaly values are, where is it? Here, even though the CPU usage was basically pure entropy because it was my kid's PC, and it's the summer, so they go from playing video games to watching movies to going outside and doing whatever. So even though this was basically pure entropy, we could see that the detection parameters never reached or went outside of 0 and 100.
Yeah, so I bet some foundational model can do a decent prediction on this time series.
Yeah. And that's going to be the fun part about trying to tune the host metrics dashboard, is that one's like more subjective, because do you want to tune it for a use case where it's like an office worker's PC where it's going to be having peaks and troughs based on work hours, or is it going to be like a public facing web application that you want to try to keep the latency as narrow as possible? or the usage on a server with consistent traffic where it's basically never changing. It looks like we have a question.
Yeah, it's again from Sandeep is, do we configure an upper and lower boundaries while configuring an anomaly? So I guess that was...
Yeah, so let me comment on this while Matthias is sharing his screen. So you do not explicitly configure upper and lower boundaries when you configure vmanomaly, but instead you can indirectly influence it. For example, you can set up parameters like scale if you want to make some manual adjustments. For example, you have your model, it works really good, but for some reason it produces symmetric predictions, symmetric confidence boundaries, but it misses some of the true positives on one side and it has big amount of small false positives on the other side. So in general, it produces decent line, but you'd like to configure it from different ends. So you can manually adjust it as well. But in general, it's either specified by model hyperparameters and it's captured by the data when the model sees it. So you don't need to configure it on your own for every query. Instead, you just rely on some distributional-based parameters which are specific to the models. So for z-score, you can configure simple z-score threshold, which is 3.0 or 3.5 as a reasonable default. Yeah, for the other model like Prophet, you might configure prediction width, which is commonly used to define the width of prediction interval around trend or around seasonality. And everything else is captured by the model itself when it sees some specific time series. So first, short answer, no, you don't. The second answer, yes, you can to some extent if you need it. If you need to make some small adjustments for a specific setup. And the way that you do it is mostly tuning ML models or using special auto-tune mode, so it's tuned for you at the cost of CPU cycles and additional time spent.
So to rephrase that, you can configure boundaries, but you don't configure hard-coded values. Because if you're just setting a hard-coded value that this value is important and you should notify somebody that it happened, you would just use a static alert and VM alert for that, right?
Yes.
But anomaly detection is to detect like a deviation from the norm rather than a set condition. So to go back to like the black box monitoring use case, you would still have alerts for like you breached the SLO that your error rate was this high or your response time was this high, but you could also detect that the response time was weird or out of what we would expect as the norm in this case.
Exactly. So you have a set of tweaks, and I believe also when it comes to the second use case, I will spend a couple of minutes, I believe we still have it, on talking on how vmanomaly is configured. So it's more about its configuration and sections.
Yeah.
So here
do you mind if I take a swing at it, Fred?
Go on.
Cool. So and feel free to interrupt me if I say something incorrect. So the scheduler is controlling when things occur. And so the default one is the periodic scheduler, which is just saying run every certain interval. So we're saying run every 5 minutes, refit everything once every year, because all of these models are online, which means that they're incrementally getting better. So we don't need to start from scratch all the time. We can just incorporate the new information into the existing model. And then the fit window is how far to look back when you're refitting the data. And then the models are we should actually do models later because they have some dependencies, right?
Just for a time sanity check too, guys, we're about 7 minutes till the scheduled end. And I know we've got a lot to cover, so we might run a bit long, but if there's any of the real meat that we want to make sure is covered, we can focus on that.
Yeah, so we briefly touch how it looks like, and then we'll go back to specific use case.
Yep. So the reader section is just saying, hey, here's my database. Since this is on an internal Docker network, I didn't have to have credentials, but you would specify like a API key or a HTTP basic auth here as well. and how often to fetch data from the database, as well as the queries that you would use for those models. And then the writer is just the same thing, but sending data back to VictoriaMetrics. So you can configure a different read and write destination, and you could also configure push-based telemetry here or pull-based telemetry. And the settings section just has some global settings like restoring state or the number of workers. This defaults to 1, but if you increase it to greater than 1, vmanomaly will run multiple worker processes. And then all of this kind of gets stitched together inside of the model section. So we'll pick on the CPU spikes. So the class is going to be the median absolute deviation online that we specified up here. Med online. Let me find it. I think I did miss a spot.
What do you want to find?
Where does median absolute, or where does mat online get defined?
It's defined in the code. I mean, you already defined it. So this
so classes
specific type of the model is median absolute deviation. Yeah.
Okay, so this would be like z-score, median absolute deviation online, which
whatever.
Incremental. Yeah. Okay. Yep. And then the threshold is for z-score and median absolute deviation, just how far away from the norm it has to be. And then detection direction, like we said before, is if is below expected, above expected, which means it's higher, below expected, which would be lower. And then if you don't define it, it's both directions. And then this is the query that we want to attach to this model and the schedulers we want to attach it to. And then Fred, what's clip predictions do?
Clip predictions actually clip your data to the data range that is defined in queries. So if you know your data range or your data profile, then it's also have no visual artifacts, and it's also can be used to produce some of the implicit checks when you have your sensor being malfunctioning and you receive something outside of your data range. So it's also being captured as an anomaly, and at the same time you see it in the graph.
Okay. And then in some of the other models, we have a couple of parameters I just wanted to touch on quick. Decay, which is new in 125, where it can bias whether or not to value new data or old data more. And by default, I believe it's set to 1, which is just everything is valued equally. But the closer this value gets to 0, the more biased it is towards new data. And then min deviation from expected, which is how far away from the expected value something has to be before it can be considered an anomaly. If it's below this threshold, the anomaly score will get suppressed to 0, correct?
Yes.
And then do you want to go over scale really quick? And I think that's everything that's important in this config.
Yeah, also, I wanted to highlight that it can be a many-to-many configuration within a single config file. So you can attach models to schedulers, you can attach queries to these models, so you can combine it in many-to-many fashion. So you can have many schedulers, many models, and many queries. So you have many queries defining different things at different granularity of the data, and then you are still able to address all of this in a single config.
Real quick,
Which,
when you were setting things like threshold, Matthias, is that something that you knew to put in 3.5 in there? Is that a default? Is it trial and error? Like where does one come up with their threshold?
I started with what Fred gave me in this case.
Right.
Yeah, so we have 2 options. One of this is to follow some reasonable default, and that's one if you're good enough, you can understand yourself as ML engineer or data scientist. So you can understand that 3.5 means like 99% was something that should be covered inside. Or you can have special auto-tuned mode around any of built-in models, so it will tune it for you. And you just need to specify expected anomaly percentage, historical data.
And there's a backtesting scheduler too. So if you want to play with that value, you could replay the scenario on, like, say this is like the very edge of what I want to define as an anomaly. So you could rerun that model with the backtesting scheduler and see what results come from it. And I believe this is something that you want to wrap a UI around in the future, Fred?
Exactly, that's what I wanted to say. That in the recent future, it will be simpler enough to just gradually reiterate until you're happy with the config, and then you just copy paste and use it in production. So it's not only about blindlessly using some predefined config, which obviously won't work for 100% of the cases, but instead you first observe your data. You see what anomaly types you'd like to track before, because if you don't know your anomaly types, it's really hard for any tool like vmanomaly to reproduce what you're thinking about. And once you do that, once you embed some business logic inside, then you can start some gradual fine-tuning, and that should be fine.
So there's a fair amount of tribal knowledge in getting it set up then, right? So, and I think that's backed up by this question that came in is, so what happens when an expected data push is not happening? Would it become an anomaly? An example is a device metric not getting pushed to VictoriaMetrics for a 5-minute period due to network glitches. So how do you define, I don't know, I think the question is pretty clear, but yeah, is if something doesn't come in, how do we look at not ingesting or non-data into the anomaly world?
That's a VM alert problem, not a VM anomaly problem in my mind. So VictoriaMetrics has some extra functionality on top of Prometheus's query language PromQL. One of those is lag, which is my favorite. So in PromQL, you would use the absent function to detect if something was missing for a certain period of time. In VictoriaMetrics, that would work, but I prefer to use the lag function, which looks back a certain amount of time and then counts the number of seconds since the last sample was seen. So for the case of missing data, you would find a metric that's available on every asset. So like in my network, I use CPU usage. If that CPU usage metric is missing for 5 minutes, I get a notification on my phone. But so VM anomaly and VM alert are working together in that case.
Okay.
So missing data would be something that you don't need machine learning to detect if something's missing, because it's a function just built into the query language.
But as far as from a trending perspective or historical perspective, if we're missing a block of data, would it be an anomaly? Like just thinking, forgetting about the alerting aspect of it. But if I've got anomaly detection and the banding is close on attempted logins, and all of a sudden those aren't being put in there, so there's zero missing data, how would the banding of anomaly detection react to that?
Yeah, so
I believe you would just have missing anomaly scores for that data, right?
Yeah, it can be addressed from query perspective. So if you define your query to have some default value for missing data, then you'll have exact zeros, and those zeros will be exported when you query range. And then, obviously, vmanomaly will catch those as anomalies. Vmanomaly on its end has indirect indicator of missing data, because once it tries to get some data in self-monitoring dashboard and in self-monitoring metrics, it will try to infer on new data. It sees that there is no data. It will increase specific counter like missing infer +1. And for that, we have alerting rule, which will be triggered like vmanomaly tried to do something, but the data was missing in that specific query name. Please go ahead and look at it. Severity is warning, so it's not critical for missing data, but if it persists for longer time, it can be seen.
Yeah. Fred, I know we're getting close to time and we've covered a lot of the best practices. Do you want to go over the synthetic example you had? Because my network's not exciting enough for seasonality.
I'll try to do that. Give me 1 second.
So is the reward for everybody who stuck around? We're getting the magic show is going to happen.
Honestly speaking, it won't be a magic show. It's just a kind of synthetic data, which I will use to demo some of the things for vmanomaly. For some reason, I can share. Give me 1 second. Oh yeah, here it is. Give me 1 second. Share screen. Share tab. Yeah, here it is.
So it definitely sounds like, Matthias, well, Fred's bringing that up, it sounds definitely like there's just a lot of power in VM anomaly, but one really has to put some thought into what they're going to be looking for, right? Like there is a lot of tribal knowledge to making it successful. I can imagine if you just went at this without knowing it or understanding it, you probably might not see a great value in it, but when set up properly, That's where the magic happens, right?
Yep. And
yeah, so
it's an enhancement, not a replacement for regular alerting as well.
Yeah.
Exactly. So it will add additional layer of support on top of existing one, rather than just simply substitution everything that you have. So here I have a demo where I set up vmanomaly, where I ingested some sample data in VictoriaMetrics, where I set up vminsert, vmagent, and any other components, as well as vmalert. So here I'm demoing you our default anomaly score dashboard, which we have in Grafana, and we have a dedicated guide for this. So first of all, we will have a global section. So suppose you already have your vmanomaly deployed and you want to explore it. But prior to that, obviously, steps that should be taken is that you need to explore your data. You need to think of your anomaly types. You need to configure some useful models and scheduling. And then once it's set up, it starts producing anomaly scores. So here on the global section, basically, there is a lot of filters. So we'll explore one time series at a time. So it's easier to consume. In a global section, you will see some of the business entity, which you can change on group by. So you can use any of your labels, which are there for produced outputs. And vmanomaly is a metric. Anomaly score is a metric. So as long as your input data has some labels, it will be present in every anomaly score as a metric. So here you can see some of the events for Kafka for specific instance. And here you can see a generalized overview of anomaly score distribution, anomaly percentage over your chosen time range, the same as its duration over time, like for how long it persisted. But later on, once you have explored more global view, and here can be a lot of entities, a lot of instances, a lot of clusters, whatever entity you have, sorted by anomaly percentage. So once you see some anomalous entity, you can drill down. And here's what I was mentioning about anomaly score and how it's been produced. So you have your default value of 1.0, which of course can be changed. So it will change and it will impact all of the visuals. But for this, you'll see your trended deseasonalized anomaly score metric over time. And here you'll see that you had some of the anomalies which hit outside of 1.0. So this might cause you firing alerts. So if you drill down to a local section, then you'll see specific time series, like specific label set, specific series index, specific model alias that produces this metric, specific scheduler that it was attached to. Here it was profit, I believe. And later on, you can observe individual anomaly score time series. Because I was filtering to the exactly one time series, it's equal to the global section. But if you have many, you'll see here individual time series. And later on, you can see some specific data, which green line is your actual data, which a model sees during prediction. This yellow line was model central prediction or point-wise estimate. And this surrounding red and blue line is the prediction boundaries. So as long as you have your real data going outside of predicted boundaries, unless you set some specific business arguments to suppress kind of this, then you'll have your anomalies being caught and respective anomaly scores being greater than 1, and respective alerting rules that are set to individual events on anomaly scores will be firing. So if we go to a longer window, yeah, you can see that the data is seasonal. And if I turn on some different scheduler, so you can see bigger picture, maybe like this. So it's also a backfilling job. So you can see that for some time it was backfilling, and ignore this line. This is just a continuation line made by Grafana. So it's not a real anomaly. It's a continuation of the last seen data point. And starting from this period in time, you'll have your periodic scheduler doing the job. So I started vmanomaly over here. It has done some backtesting of historical data for 2 days, I believe, and it started doing prediction in production scheduler. And as long as you have your, but by the way, this is a type of contextual anomalies, when you have your seasonal patterns and when you have data points of similar magnitude to your expected time range, but they are off-season, like spikes here and drops here. So this can be hardly taken by regular alerting rules configured on raw metric values. So basically, this is the case for specific time series which has seasonality, but of course it can be different one. Give me 1 second. Yeah, for different types of series, it can be different. Like for simpler models, you can use, for simpler data and for simpler types of anomalies, you can use simpler models, like Mathis mentioned, like median absolute deviation, maybe online seasonal quantile, which has season turned off to be online. And here you can see some spikes in processing times in milliseconds. So as long as it's configured to not implement some minimal deviation from expected, all of these spikes are considered anomalies. But if for some reason you want the spikes to be significant only from maybe plus 300 milliseconds, then you just add one single line to your model configuration that works on this data, and hot reload catches it, and from this time you will have spikes on the bigger of magnitude being captured as anomaly and everything else being suppressed. And here, if we observe some real line, you have not only some point-wise anomalies, but you have also regime change. So for some reason, your regular millisecond processing time goes up from like 20 seconds to 100 milliseconds. And this might or might not be captured with simpler alerting rules, but from time series perspective, it's definitely an anomaly because it's a change point and it persisted for some time. So on historical data, you would receive, let me check. Yeah, here you can see the bump in anomaly score percentages over time. And here you can see a bump of anomaly scores greater than 1 until for different scheduler, which is online and periodic, it will slightly resolve because model will adapt over time to a new pattern as long as it remains new pattern. So this is basically how it looks like from our exploration perspective. And what's more important here is that it really depends on what you want to get. So from time series perspective, all of these spikes are anomalies. Or maybe this period was also an anomaly. But from business perspective, it might or might not be. So it's better to detect it on your end, on business end, because no model is a silver bullet. How complex it is, it doesn't matter. It just does its prediction job or does its anomaly detection job. And it's not so obvious and not so good to just think that it works in every situation.
So, Fred, how many models does vmanomaly support currently?
vmanomaly support a set of built-in models, which with support of custom models if the customer wants to. We are single Python API. For now, we have a set of model types. Let me go back to StreamYard. Yeah, so for now, we have different models for different data profiles. Like for the simplest one, as I demoed the second time, which are detrended, like it has no visual trends or seasonalities, you can use so simple as z-score or median absolute deviation or their online counterparts for being just effective model type. For different one, when we have trends or seasonalities or multiple seasonalities or maybe trends plus seasonalities plus some change points, it's better to use predictive models, which we also have a few. But I'd suggest to start from profit model being the most flexible out of this. For multivariate interaction, for example, if you want to feed in several time series at once, maybe grouping by specific business entity, like setting all the metrics for specific instance to a single model, or grouping them previously and setting to a single model, you can use multivariate models, for example, isolation forest for that. Or if you use specific model that works best for you, even before you worked with vmanomaly, then you can still plug it in via API and continue benefiting from what you get.
And Mark, to answer your question, I think there's like 10 or 11 full models on our website, and you can add in your own as a Python class. But I believe some of them are somewhat duplicates. Like there's median absolute deviation or MAD, and there's MAD online. So in reality, it's probably like 6 or 7 like fully unique ones, because some of the models are just like the online version of another model.
And when you say Mad Online, I think you're not talking about Mad Magazine that I can fold the back cover, right? So,
or me just being on the internet in general.
Yeah, awesome.
Yeah, for sure.
Hey, we have one more. Oh yeah, here you go. Go ahead.
Yeah, we have one more question, and then I think we're at a good spot to wrap up.
Yeah.
Yes.
So if you have multiple clusters, is it possible to detect anomalies at a cluster level, even if the metrics are at like an individual node in that cluster level? The answer is
go on with this.
I'm pretty sure that the answer is yes. You would just need to make sure that the query is aggregating by the cluster. So if you want to detect like the latency of like the kubelet API on a specific server or something like that, you would make sure to aggregate using like average or some other aggregate function, and you aggregate by cluster. And then you would get one anomaly, or you would get one time series per cluster that you would run anomaly detection on.
Also, nobody prevents you from producing individual anomaly lines, like anomaly scores for individual nodes or different sub-entities. And at alerting time in vmalert, you just aggregate those with sum or average or minimal over time to get cluster level anomalies. But if you want to fit in some context, you'd either use multivariate models or you'd either use different queries. So it somehow aggregates individual time series into one big time series.
Awesome.
So there can be a few options to address this question.
Right. Well, it's amazing how fast the time has gone. I know we're running about 15 minutes late, and you guys have things to do. I'm just really excited that there's so much on vmanomaly that we could just keep going. So I think what I'd love to do is, we're obviously going to be sharing more information about vmanomaly, tips, tricks, different things. So that'll be all across our website. You can certainly reach out to us directly in many different ways if you have any more questions. And if there's interest, I think we could certainly, it sounds like we can either carve some out of this or create some follow-up videos with you, Fred, of just some more interesting tips and tricks and have you guys go. So that was, it was a really good session. I thank you both so much for your time. Fred, your expertise was awesome. And,
thanks for having me here. And I believe that's a good direction, because we didn't mention, I wanted to mention, but we didn't have time to mention auto-tune mode. And hopefully next time it will be referenced within graphical user interface. So it's more fun to follow.
Yep. I'm looking forward to the GUI. Yeah. Awesome. Well, thanks again. Thanks for everybody for sticking around. I know it was a bit longer. Hope you all got some good value out of it. We're looking forward to seeing you at the end of August. We'll share some information on topic and what's coming up. And again, if there's any questions, reach out to us in all the different ways in our public Slack, via our website, anywhere there is. So thank you all. Have a great day.
Thank you too. Next Thursday. And one quick note, we also share the presentation because it has two slides that we didn't cover, which exactly has some tips and tricks of how to better deploy vmanomaly and what steps to follow.
Perfect. Yeah, we can add that to the link into the YouTube description, so it'll be there for even people who are watching this on demand later. But Thanks again, everyone. Have a great day, and we'll see you next month. Bye.
See you soon.
See ya.